Welcome to Academic Gain Tutorials. In this video we will learn about the working procedure of an air conditioner. In other words, we will learn how an air conditioner works. So, let's get into the topic. First of all, let's see the major components or parts of an air conditioner. Here, we have a compressor, there is a condenser, an expansion valve, and finally, an evaporator. It can also be called a cooling effect generator. We have a fan over here, and here. And these are the connecting pipes that connect all these parts together. Thus a closed loop is formed. Now, without further ado, let's look into the working of all parts of this air conditioner through animation. We all know that the basic principle of air conditioning is to remove the heat from one area and replace it with chill dry air and expel the hot air to the outside atmosphere. And for this exchange of heat, we use a special fluid which is called refrigerant or coolant. We can think of the refrigerant as the messenger or traveler, because this refrigerant is the actual carrier or medium of heat exchange between the external environment and this internal components. By brand name, we call this refrigerant as Freon. Thus, the coolant or refrigerant, Freon, is a fluid that flows through these connecting pipes and parts of air conditioner, and changes states from liquid to vapor, or vapor to liquid at convenient temperatures for the refrigeration cycle or air conditioning process. Now, at the first step, the compressor starts working. The job of the compressor is to pressurize or compress the refrigerant Freon, and we know that if pressure increases, it also increases the temperature. So, when the compressor compresses the refrigerant Freon in its gaseous state by squeezing the gas very tightly together, it will heat up. We heat up the refrigerant in order to get its temperature higher than the outdoor temperature. Since heat naturally flows from a hotter to colder bodies, in order to dispense heat outdoors, the refrigerant must be hotter than the air outdoors. This is why we need the compressor to increase its pressure and thus its temperature. Then, this high pressure and high temperature gas vapor of Freon will go to the condenser through these connecting pipes. After that, in the condenser, this high pressure and high temperature gas vapor of Freon will change its form from gas to liquid in the same temperature. That is, the temperature will remain same. The condenser will just change the physical state of the refrigerant Freon from gaseous form to liquid. This condenser coil is in the outdoor air conditioning unit placed outside of our home. The heat energy is absorbed from the hot gaseous refrigerant, and with the aid of the condenser fan, this heat is expelled to the environment. As the heat leaves the refrigerant to the outside environment, it turns back into a liquid. We can think of it as the opposite of the evaporator coil, because the evaporator coils contain cold refrigerant, whereas the condenser coils contain hot refrigerant. Now, this high-temperature condensed liquid refrigerant will leave the condenser and enter the expansion valve through this connecting pipe. When the refrigerant leaves the condenser in its liquid state, it has already given away heat to become a liquid from gas, but it is still too hot to enter the evaporator coils. Before the refrigerant passes to the evaporator coils, it must be cooled down. This is where the expansion valve comes in. We know that compression and expansion are opposites to one another. Here in compression we needed to increase the temperature of refrigerant, so we increased pressure by compressing the refrigerant Freon and thus increased temperature. So, similarly, now we need to cool down the temperature of the liquid refrigerant coming from the condenser, so we have to cause expansion, which will reduce the pressure between the refrigerant molecules, which will cool it down simultaneously. Now, this is what happens in the expansion valve. The expansion valve depressurizes or lowers the pressure of the refrigerant and cools it down. It also controls the amount of refrigerant or voltage flow entering the evaporator. Now, the low-pressure cold liquid refrigerant enters the space where we want to produce cooling. That is, this cold liquid is now ready to absorb heat from the indoor environment and produce cooling. So, this low-pressure cold liquid refrigerant enters the evaporator coils. These evaporator coils are very important to an air conditioner. The evaporator is the indoor air conditioning unit we pulse inside our home, where the air conditioner actually picks up the heat from inside our home. The copper tubes of evaporator receive the depressurized cold liquid refrigerant from the expansion valve, and when our indoor air blows over the cold coils, the heat from inside the home gets absorbed by this cold refrigerant. This is because of the second law of thermodynamics, which states that heat flows naturally from hot to cold. As this cold liquid refrigerant absorbs heat from the indoor air, it starts to evaporate to form a vapor. Thus the refrigerant in this evaporator unit absorbs heat from our home and converts into vapor, and as a result our home environment loses heat and cools down. This fan circulates the cold air from this coil surface for the cooling effect. Now, this hot gaseous refrigerant after absorbing heat again goes through the compressor, thus the process is repeated continuously in a closed loop, and the air conditioner keeps cooling our home continuously. So, let's just summarize what we learned about how the refrigeration cycle works. The return vents, located inside your home, suck in hot air from inside the room. The refrigerant picks up heat as air flows over the evaporator coils, which are very cold. Once the refrigerant absorbs a certain amount of heat from the indoor air, it then discharges it to the compressor, which pressurizes and heats up the refrigerant. After passing through the compressor, it flows through the condenser coils. A big, often loud condenser fan helps to push air over the condenser coils to facilitate heat transfer outdoors. Refrigerant then cycles back over an expansion valve, depressurizing it and cooling it down. It then performs the same heat absorption process over and over again. Thank you for watching this video. If this video was helpful, subscribe to my channel Academic Game Tutorials for more updated videos.